Today, I have this for you guys and check this out. What's the exponent here? Negative 1 over x squared. Does this still work? Yes. Thanks to the 1 minus, this integral actually still converge. Let's go ahead and integrate 1, which is just x, and then put down the minus. Now the question is, how do we integrate e to the negative 1 over x squared? The answer is, we cannot without special functions. If you want to use special functions, you can check out my related video. But here, let's first just focus on the integral e to the negative 1 over x squared power. Well, as I told you, we are not going to use special functions to integrate this. So what can we do? Why don't we try to differentiate this instead, and then just integrate 1? Yes, differentiate one part, integrate the other, integration by parts. Of course, let's do the DI setup. Plus, minus, differentiate e to the negative 1 over x squared, and then integrate 1. Integrating 1, we get x. Differentiating this, we get e to the negative 1 over x squared. And don't forget the chain rule. Multiply by the derivative of that. And this is negative x to the negative 2 power. So bring the power to the front, minus 1. That will give us positive 2, and then x to the negative 3. Now, this times that, it's the first part of the answer. So we have x, e to the negative 1 over x squared power, and then multiply these two things together and put that inside of an integral. And that's a negative, yeah? So it's a minus integral, and this times this is x to a negative 2. We can put on the bottom, like this. And then I will just put the rest on the top. 2e to the negative 1 over x squared power. Yeah. And keep in mind, we will still have to put this back here, but let me tell you, it's beneficial if we just finish this integral first, and then this and that can actually help us to finish the rest. You'll see. So this right here, remember, it's when x equals 0 to infinity. And to figure this out, in fact, we can just do a quick goose up. Check this out. This is negative 1 over x squared. If we want to connect this to the Gaussian integral, we must have negative something squared, right? So right here, let's put u to be 1 over x, just that. And then differentiate both sides. Du equals negative 1 over x squared dx. Works out perfectly. And here, let me just multiply negative x squared on both sides. Dx equals negative x squared du. Now, take this to the u world. We will have the negative integral. When x is 0, if you put it here, you are really taking the limit. This is technically 0 plus. 1 over 0 plus is infinity. So u is infinity here. And then if you put x to be infinity here, 1 over infinity is 0. So u will be 0 here. And not finish the rest. We have 2, e negative, 1 over x is the u, and here we have the squared, so it's u squared. Over that, I want to show you guys a cancellation, that's why I'm writing it like this. And then of course, the dx is this, which is negative x squared du. Cancel, cancel, very nice. And as you can see, this is kind of like out of order, but don't worry. I'm going to use this negative to change the order back. This negative stays, and then we have the integral, and it will go from 0 to infinity. Let me put the 2 on the outside, and then this is just e to the negative u squared du. What's this? This right here is precisely half of the Gaussian integral, which you will get square root of pi over 2. Multiply by negative 2, so all in all, we get negative square root of pi. And this right here, it's the result for this. Alright? Alright, now we just have to put this back, and remember it's minus this and that, so it will be a minus x e to the negative 1 over x squared power, and then this right here, it's a minus, but we multiply by that minus, so it becomes a plus. And we have the square root of pi here. Why do we still have the x's? Yeah, don't worry. Now, this part, we take the limit from 0 to infinity. If you put infinity to here, and here, you get infinity minus infinity. It's indeterminate. We have to do more work to investigate that. So here, let's go ahead and finish this. Focus on the limit as x approaching infinity. Let me factor out an x first, and then we have 1 minus e to the negative 1 over x squared. Well, that will give us infinity. Put infinity to here, negative 1 over infinity is 0. 1 to the 0th power is 1. 1 minus 1 is 0. So this is infinity times 0, still indeterminate. Don't worry. Put this x down, becomes the limit as x approaching infinity, and we will have 1 minus e to the negative 1 over x squared over 1 over x. Put the x down. Yay. Then we will get 0 over 0, L'Hopital's rule. So here we go. Differentiate this, differentiate that. So thanks to L'Hopital's rule, we can just focus on the limit as x approaching infinity. So here we have negative, that's just 0, so negative e to the negative 1 over x squared times this derivative, which is what we got right there. So multiply by 2x to the negative 3. And the derivative of that is negative 1 over x squared. And we can simplify this whichever way that you would like. Perhaps I will just multiply the top and bottom by, well, this and that cancel. I'll multiply the top and bottom by x squared for you guys. Cancel. So we're looking at the limit as x approaching infinity. And then 2 is 2. E is e, and then that is still that. And this times that is just x to the negative 1. So we have this and then just divided by x. Oh, that's a horrible notation, sorry. Much better. Now if you put infinity to here, on the bottom is infinity. On the top here, negative 1 over infinity squared, it will be 0. So you really just get 2 over infinity, which will just give you 0. So we conclude that that will give us 0. When you put infinity to here, we get 0, all right? So that's that. And what if we put 0 into here and there? Well, check this out. If you take the limit as x approaching 0, and we have x times 1 minus e to the negative 1 over x squared, that is 0, right? That is 0 times, this is 1 minus e to the negative 1 over 0 squared. 1 over 0 is infinity, but that is going to be negative infinity, yeah? So this is negative infinity. E to the negative infinity is 0. So in another word, you just get 0 times 1 minus 0. 0 times 1 is 0. So this part is also 0. Believe you or not, when you plug in infinity, you get 0. When you plug in 0, you also get 0. Yes. So to show work, this right here, we just get 0 and then plus that square root of pi. And finally, I fit everything on the whiteboard and I have that space, I don't know why. But finally, the answer is square root of pi. Hey, I know you like calculus because otherwise you wouldn't watch this video, right? And now, if you want to learn more calculus, then one great place for you to continue is our sponsor today, Brilliant.work. Brilliant is an online learning platform with thousands of interactive lessons in math, science, and computer science. And of course, let's take a look at their calculus lessons. You see, not only they will teach you all the integration techniques, but also the lessons are all interactive, so you are not just going to be memorizing the formulas. With cool animations and storytellings, you can really enjoy learning the calculus concepts and applications. And as a calculus teacher, students often ask me how they can learn calculus on their own in a fun way, and I will always recommend Brilliant to them. And right now, you can even try Brilliant for 30-day free. So go ahead and check them out. Use the link in the description, brilliant.work/blackpenredpen, so that you can get 20% off discount. I want to thank Brilliant for sponsoring this video. I also want to thank you for checking them out.